Welcome to Cosmic Compass, where we journey through the mysteries of the universe together. Today, let's unravel the story of a planet that has often been overlooked, Mercury. Despite being the closest planet to the Sun, and on average, the closest to Earth, Mercury remained unexplored for decades. Why was it ignored for so long? And what did we finally discover when we dared to go there? Let's dive into one of the most challenging missions in planetary exploration, the voyage of Messenger. When humankind first began sending spacecraft to explore our solar system, the order of visitation may surprise you. In 1962, Venus was the first to be reached. Just 3 years later, Mars. Then, in 1973, Jupiter. Only afterward, in 1974, did a probe finally fly past Mercury. And that's odd, isn't it? Mercury is the innermost planet, and on average, it is actually the closest planet to Earth. Its minimum distance is about 77 million kilometers. Compare that to Jupiter, which at its closest is 588 million kilometers away, almost 8 times farther. Yet Jupiter received multiple visits in the following decades, while Mercury was ignored for over 30 years. So why was Mercury left behind? Was it considered uninteresting? Did that first mission tell us everything we needed to know? Not at all. In fact, the first flyby mapped less than half of Mercury's surface. The real reason is far more intriguing. Mercury is one of the most challenging worlds in the solar system to reach. Let's consider why. Mercury orbits in a furnace. Surface temperatures can soar to 430 degrees Celsius, hot enough to melt lead hotter than any oven you've ever used. Any spacecraft venturing there would need extraordinary protection from the sun's radiation. But that's not the only problem. The sun's immense gravity pulls everything inward. When we launch a probe toward Mercury, instead of gently approaching it, accelerates faster and faster, dragged by the sun. Imagine trying to swim upstream in a raging river, or running up a downward escalator that never stops. That's what it feels like. To slow down enough to be captured by Mercury's orbit, a spacecraft would need an enormous amount of fuel, far too much for a small Discovery-class probe to carry. For decades, this barrier made a long-term mission to Mercury seem impossible. After the Mariner 10 flybys of the mid-1970s, Mercury exploration was effectively put on hold. Scientists had no clear solution, but that changed with one person's clever insight. In 1985, an orbital mechanics expert named Chen-Wan Yan proposed an ingenious solution. Instead of flying straight to Mercury and fighting the sun's pull head-on, why not take a longer winding route through the solar system? His plan relied on gravity assists. By carefully timing flybys of Earth, Venus, and even Mercury itself, a probe could gradually shed speed. Each encounter would act like a cosmic slingshot in reverse, bleeding off velocity little by little, until the craft was finally slow enough to be captured by Mercury's gravity. This wouldn't be a quick trip. Yen's calculations showed it would take about 6.5 years, looping around the sun 15 times, covering 7.9 billion kilometers. Along the way, the probe would pass Earth, once Venus twice, and Mercury 3 times before finally slipping into orbit on the 4th attempt. At first, the idea wasn't pursued, but in 1998, NASA began taking interest. By 2004, a spacecraft was ready. The Messenger mission, short for Mercury Surface Space Environment Geochemistry and Ranging. Messenger was compact by NASA standards, just 1.8 meters long, weighing 100 kilograms, with a ceramic heat shield to withstand the sun, 2 solar panels to provide power, and a carefully chosen suite of instruments. Scientists wanted to unlock Mercury's secrets, its chemical composition, geological history, magnetic field, and even the nature of its mysterious core. The stage was set for one of the most daring journeys in planetary exploration. Messenger's journey began with a familiar checkpoint, Earth. In its first year, it swung around our planet, giving scientists a chance to test its instruments on something they already understood: Images of Earth and the Moon, data from our atmosphere and magnetosphere, all confirmed that the spacecraft was working flawlessly. But heading sunward required more than tests. Engineers had equipped Messenger with a clever trick. Its solar panels weren't just for power, they acted like tiny sails. By tilting them against the flow of solar radiation, the probe could use sunlight itself to slow down in the same way sails catch the wind on a ship. The push was tiny, almost imperceptible, but over billions of kilometres, it made a real difference. In 2006, Messenger flew past Venus for the first time. Unfortunately, the timing placed Venus on the far side of the Sun, carting off radio contact with Earth. The spacecraft still gathered images and data, but mission control had to wait anxiously until contact resumed. By 2007, Messenger returned to Venus again. This time, another spacecraft was waiting, ESA's Venus Express. Together, they performed the first simultaneous measurements of Venus's charged particle environment, a rare scientific bonus. Then came the main event, Mercury itself. The first flyby in January 2008 went smoothly. The second was also a success. But during the third in 2009, disaster struck. Messenger suddenly entered safe mode, an automated shutdown meant to protect its systems. For 7 hours, the spacecraft was silent, adrift in uncertainty. The timing could not have been worse during this flyby. Messenger had to pass through Mercury's shadow, relying only on its batteries for power. A misconfiguration in its power management software caused the system to fail. Can you imagine the tension in the control room? After travelling billions of kilometres, years of planning seemed at risk. But when sunlight finally returned to its panels, the spacecraft rebooted, recovered and carried on. The mission had survived. On March 11, 2011, Messenger achieved what once seemed impossible. It slipped into orbit around Mercury. For the first time in history, a spacecraft would remain there, studying the planet, not in fleeting glimpses, but day after day. Its orbit was elliptical, ranging from just 200 kilometres above the surface to as far as 15,000 kilometres out. Why so uneven? Because Mercury itself radiates intense heat, acting like a mirror reflecting the sun. Staying close for too long would have been fatal, even with the heat shield. By pulling back, every 12 hours the spacecraft could cool off between close passes. After decades of waiting, we had finally arrived at the solar system's innermost world. Originally, scientists hoped Messenger would last just 1 year in orbit. If it could return 1,000 photographs, the mission would be a success. Instead, Messenger lasted 4 years, quadrupling its expected lifetime. And it didn't just return 1,000 images, it captured over 200,000. For the first time, Mercury's surface was mapped in high resolution and full colour. We saw vast plains, towering cliffs and impact craters with incredible detail. The probe also made groundbreaking discoveries. It revealed that Mercury's core is much larger relative to its size than Earth's, suggesting a unique formation history. It detected evidence of volatile elements like sulfur and potassium, challenging previous assumptions that they couldn't survive so close to the sun. And it confirmed the existence of water ice, hidden in permanently shadowed craters at Mercury's poles, frozen oases in one of the hottest places in the solar system. Messenger even captured images of comets and other planets during its long journey, expanding its scientific reach beyond Mercury itself. What began as an improbable mission turned into a treasure trove of planetary science. By December 2014, Messenger's carefully conserved fuel was almost gone. Engineers used the last bursts of its thrusters to keep it aloft, lowering its orbit closer and closer to Mercury's surface. At one point, it skimmed just 25 kilometres above the planet. Finally, on April 30th, 2015, after more than a decade of travel and discovery, Messenger's journey came to an end. The spacecraft impacted Mercury's surface, leaving behind a silent mark on the very world it had studied so thoroughly. It was a bittersweet ending, but not the end of Mercury exploration. In 2025, ESA and JAXA's joint mission, BepiColombo, is set to arrive. Unlike Messenger, BepiColombo will separate into 2 orbiters each, with specialized instruments promising to reveal even more about this enigmatic world. So let's ask ourselves, why does Mercury matter beyond its scorched surface and proximity to the Sun? It holds vital clues about how rocky planets form and evolve. By studying it, we understand not only Mercury, but the story of Earth-Mars, and perhaps even planets around distant stars. The Messenger mission showed us that even the smallest planet can hold the biggest surprises. And now, we wait for the next chapter to unfold. As we've seen, the Messenger mission transformed Mercury from a forgotten world into a planet rich with secrets and surprises, from uncovering water ice in the shadows of its craters to mapping its entire surface in stunning detail. Messenger left behind a legacy that reshaped our understanding of the inner solar system, and this is only the beginning. In 2025, BepiColombo will continue the story, giving us an even closer look at the mysteries Mercury still holds. If you enjoyed this journey, don't forget to subscribe to Cosmic Compass for more explorations of the cosmos. Share this video with anyone curious about our solar system, and let's keep reaching for the stars together.